will never make you do anything other than a size of 5, so you can just assume the size is always 5. You're gonna ask a question? This collection, I would do numbers of our collection.
Welcome to
Why
the
do we do
stream.
that?
Doing homework.
Because this means that the loop will always end
Taking programming
at
Runday Fullsail
1
University.
less than the size of the collection. And we know, we talked about that previously, that the last element in the collection is always 1 less than the size, right? So for example, if I wanted to grab the last item in this numbers variable, or in this numbers collection, so we would do numbers. If I had size in a variable, I could do that, and this would always give me last element, right? So this loop would work. And if I wanted to see out every single item in this collection, I would do numbers I, like that. And I would write every single item to the of the collection out to the to the console. Like I said, this is the most common pattern in programming that I have encountered. So why is this common? Because it's used all of the time. Consider, like, if I am making a social media application, okay, fine. If I'm making a social media application, right? This is a collection of views that are being added to a list. So I'm just gonna say, grab all the views, and for each one, create these things and associate them with a position, right? And then I say, okay, I tapped on this one. It's gonna tell them, okay, grab data number 2 and bring up the details for data, or data number 1 in for index number 1, position number 2. Pull the details, right? It's a very, very common recurring pattern in computer science. All right, so zoom out a little bit. So there is one thing that you will need to do in one place in the lab, and it's probably one of the hardest tests in the entire class. But before we do that, does anybody have any questions about this stuff? Because this is the majority of those things. Yeah. You can just, that's what this is. That's status, yeah. Use the other status vector, it doesn't need a size. Any other questions? Yeah.
I don't know if you're back this one or not, but earlier you were pointing out that input into array.
Yeah.
From the CN method or CN method.
Yeah, I mean, CN is just an example of input, right? But it could be any kind of input. It could be from a raw value. It could be from a variable, whatever. So like, for instance, numbers, if I want to put something in numbers, I'd have to provide an index and I'd provide a value. If I want to get something out, so like int number, number, it would be the same way. So it just depends on, like, this right here is effectively taking the place of a variable name. That is the identifier.
So if I wanted to be able to put multiple inputs, say now how many vectors can I put? I most certainly need vector first of all. Because an array would be a fixed number based on names. But I say I wanted them to figure out how many data I need. For example, I've used
Yeah, practical. Yeah. We ask them how many things you want to store. They give us a size. We then update our existing vector by initializing a new vector with a size on top of it. Yeah.
Are you going to give them the detail about how to do that?
That's what this is right here. Except instead of this being a hard-coded size, this would be an integer variable that you would use here, that you would capture and then use to create the size. So this is me creating the vector. This would be like the top of the file, right? When it says like initialize the vector, cool. And then when we prompt them for user input, you say, okay, give us a size. You store that size in a variable, right? Like this could very well just be like int size is equal to 5, and I can say, okay, now give this size. So it's very similar to that pattern.
But I think the biggest confusion you define, if like, is that just the initial size of it, and if they go past that, then go?
It's just gonna be anything, right? This could be like, I'm gonna very quickly shit this out, so just, if it doesn't make complete sense, just so it could be, std string, input is equal to an empty string. Oops, sorry. And then, int size is equal to, oh no, sorry, hold on. Line is stdcn, store the user input in input, and then, int size, well, we don't get int size. The int size is equal to input converted to a int, right? So that very easily just be that. It doesn't matter really. As long as this is an integer, that's what matters. I'm kind of talking mumbly, and so I don't know if it's getting all the way over to you.
Yeah.
Alright, cool. So one thing you guys will have to do is you will have to put a loop within a loop. Carl will hopefully be here soonish, so we can go over the lab. But a loop within a loop is something that's not super difficult, but there are some nuance to it, right? So let's say I want to loop through numbers, right? So while I is less than numbers.size, I plus plus. Now I need to do a second loop, right? So for int, one thing to keep in mind here is I cannot reuse I, because I already exists. So if I use I here, even though it would be valid code, it would really get wonky as far as the execution goes, right? So I'm gonna use a different variable name. Typically, we just use the next letter. So we use like I, J, K, L. I've seen up to L. It could probably go further, but that many nested loops is insane. So we're gonna say J is equal to 0, while J is less than numbers.size, J plus plus, all right? Now, the way this is gonna work is this is gonna run once, and then this is gonna go fully through the next thing. So this is gonna run once, this is gonna loop as many times as it needs to, so for the size. Then it's gonna come out here, and then this will loop a second time, and this will loop as many times as it needs to. This will go a third time, this will loop as many times as it needs to. So if this was a size of 5, it would go 0, and then it would go 0 through 4, 1, 0 through 4, 2, 0 through 4. Sometimes this is necessary. It's pretty common to have to do one loop inside of another loop. So why would you guys need to use this, right? So in the context of your guys' lab, you guys are going to have to do a test that gives you a collection of names, and it's going to ask you to find if there's any names that are repeated, right? So if any name shows up 2 times in the collection, you should say true. So how do you do that, right? Well, first of all, let's think of it like this. You need to take every single name and compare it to every other name, which in turn requires 2 loops, right? Because you have to loop first, grab the first name. Okay, now with the first name in hand, grab every other name, right? So still loop through all the names and compare them to each of the other names, but you can't compare it to itself, because if you compare it to itself, it'll always be a duplicate. So compare it to every other name, but skip the name that you are currently looking at. And you can do that by evaluating the position, right? Because you pull the name from a position. So if like John is in position 0 and in position 4, there's duplicates. I'm working out the problem for you guys, I'm making it easy, but I know it's also the hardest one. So just keep those things in mind, right? All right. So we have adding things to a collection, we have removing things from a collection, we have dynamically getting a size, we have reinitializing, we have the short hands, we have the long hands, we have a lot of different stuff here.
68 pages. There's no way I can read all of that. And that's why it crashed. 68 pages is a lot. This might be too much. Sixty-eight pages. Took 9 seconds for it to read 68 pages.
So, just where we are right now, do you guys have any questions about any of this? Yes. say that's a very smart solution. That was a very good idea. Yeah, I was kind of breaking it down in like the most elementary way, but that's smart solution too. Did you pass all the tests? And you're good. Now, one thing to note, right? It's going to come up several times. It's also going to come up in that particular test, right? We can use the break keyword to immediately exit out of a loop. So if I put break in here, we saw this again. We saw this on Wednesday. If we put a break keyword in here, when break is hit, right, then we'll immediately exit out of a loop. This is going to be important for that test because let's say my data is, Doug, John, and Bob, right? So, and I have like a variable. So we say like bool duplicate is equal to false by default. So we're gonna take Doug and we're gonna compare it to Doug, and then it's gonna be true. Boom, we're true, cool. But if we go Doug and then we check John, then it's gonna be false, right? So in the event that Doug is in any other position other than the last one, if we keep looking, it's inevitably gonna override it with false. So just keep that in mind. All right, any questions about this? All right, for those of you guys online, Carl is here now. We're gonna take our second break. We're gonna have to close down the Zoom meeting, come back here at 2:55, and then Carl can cover the coding demo part and the lab itself. Before we shut down, any other questions about any of this? All right, I will see you guys all again on Monday. Have a good weekend. Oh wait, how do you add or change every other word? Chris, if you wanted to change every other thing, then I would decide if it was an odd or even position, depending on which one you want to do. And we looked at how to check an even position, right? That is modulo 2 is equal to 0. So you want to see, is it equal to 0? You want to check that. You need to use that to determine an even number, right? And that'll help you determine if you want to change stuff on odd or even. But that should be enough to get you out, cook with that for a little bit. But I'll see you guys later. Have a good weekend.
Let's see what this one is. I'm assuming they changed instructors. Yeah, they changed instructors.
And we'll get started on the live demo.
All right, I'm gonna give it a few minutes to see if anyone else joins for the online again. After I put that thing up there,
And we'll get started on the live demo. I recommend following along. You don't have to. This will end up on Discord.
if I go too fast, please feel free to say something. I tunnel vision, so if I don't see your hand, I probably won't see it, and I'll just continue unless somebody says something. While we're waiting, I'm gonna add a bunch of notes to kind of structure everything. So far, the only thing code-wise that I've actually added to include three-string vector.
go to bed at 6 o'clock. It's 11:40. Drop the internet. I'm gonna make a GNC protein shake. Well, technically, I'm gonna make a amino acid shake. Hopefully, it'll make me strong. These are the things we'll be adding to them.
Alright. I haven't seen anyone else join, so we'll get started here. Again, the only thing code-wise that I've added is string and vector. And add some more comments, and then we will create a few variables.
No, I have to go get celery. I have to do like celery.
Alright, so with arrays, it's going to be very similar to a variable.
Can I ask for my pineapple juice?
We're going to have our type, and then our identifier, square brackets, and inside of the square brackets, it's going to have to be a whole number. It's going to dictate the size of our grader. I'm going to say 3. And this creates an int array called myIntCar with the size of 3. We can also, I believe in this language, assign values at the same point. So we're going to make a short array, a short array. Its size doesn't matter. And we're going to initialize it to have all set of values of 1, 2, 3.
Open.
We can do the same thing for pretty much any type, including a programmer-defined type, which we'll talk about more on day 6 and 7, or sorry, 7 and 8. But we can do string, bool, short, long, all the types we've done before.
Not strong.
So we have 3 different examples of arrays on the screen right now. We have our int array, my short array with values, my string array with values. Now we can do the same thing with vectors. However, it's going to be a little bit different because we're not starting with the type, we're starting with the vector keyword. And inside of the less than greater than is going to be our type. So in this case, we'll do a vector length, my int vec. We can also do one like arrays with any other type. So we'll do short as well. However, if we try to provide size and a section of values on vectors, I believe it gives us an error, but we'll see that here in just a moment. Alright, yeah, it looks like, we get errors when we try to provide value and size to a vector. So what I'm gonna do is comment that out
So, now,
and just leave the size there.
one of each.
And then should be for size. In this language for a vector should be parentheses compared to square brackets, length arrays, and arrays. So there is a difference between giving a size to an array and giving a size to a vector. Double check, yeah, still. So we have multiple examples of arrays and vectors. We can see that their declaration is similar. However, with arrays, it's going to be type, they identifier size, and we can initialize values if we want. For vectors, it is going to be a vector of identifier. We can either provide values or provide an initial size. So, primary difference between both is in this language,
Actually,
arrays are not, for now. Meaning once we've declared them, we cannot resize them. We would have to basically create an array if we wanted.
The device. The device is going to be sad.
Also, arrays have no publicly available variables or methods like a vector key. We can denote that by typing out. So we'll do an array. This is to be expected, nothing else will pop up. So we're going to comment that out. And we're going to do the same thing for a vector. So we'll do my short vector. The moment I type the dot operator, it's going to give us a list of all these methods that we have access to. Now, only a handful of them actually get talked about in the course, so just be mindful of what you actually utilize when you use the dot operator and you're choosing your method as well. I believe in the slides, it's pushback, size, I think that might be it. But we'll see more of that a little bit later, so we're going to comment that. So for vector size, just going to get the total amount of items inside of the collection, or if we have a vector that has no items but a size defined, is going to get that as well. So for my short vec, we have 1, 2, 3, 4, 5, 8 items. And then on my string vec, we have size of 40. So you can see out size of short vec, and then do my short vec dot size. And we can do end out the end of that one, and then we'll do the same thing for the my string vector.
Then we'll keep working. This video is only an hour long.
Else join, so I'm sure notes is kind of structure everything. So far, the only thing code-wise that I've actually added to include is restrict vector. haven't seen anyone else join, so we'll get started here. Again, the only thing code-wise that I've added is string and vector. And add some more comments, and then we will create a few arrays. Alright, so with arrays, the way to declare them is going to be very similar to a variable. We're going to have our type, and then our identifier, square brackets, and inside of the square brackets, it's going to have to be a whole number that's positive. This is going to dictate the size of our array here. So I'm going to say 3. And this creates an int array called myIntR with a size of 3. We could also, I believe in this language, assign values at the same point. So we're going to make a short array, called a short array. The size doesn't matter. And we're going to initialize it to have a set of values of 1, 2, 3. We can do the same thing for pretty much any type, including a programmer defined type, which we'll talk about more on day 6 and 7, or sorry, 7 and 8. But we can do string, bool, short, long, all the types we've done before. So we have 3 different examples of arrays on the screen right now. We have our int array, my short array with values, and my string array with values. And I can do the same thing with vectors. However, it's going to be a little bit different because we're not starting with the type, we're starting with the vector keyword. And inside of the less than greater than is going to be our type. So in this case, we'll do a vector events, myIntVec. We can also do one like arrays with any other type. So we'll do short as well. However, if we try to provide size and a section of values on vectors, I believe it gives us an error, but we'll see that here in just a moment. All right, yeah, it looks like we get errors when we try to provide value and size to a vector. So what I'm going to do is comment that out and just leave the size there. And then should be for size. In this language for a vector should be parentheses compared to square brackets like there is an array. So there is a difference between giving a size to an array and giving a size to a vector. Double check, yeah, still on. So we have multiple examples of arrays and vectors. We can see that their declaration is similar. However, with arrays, it's going to be the type, the identifier, size, and then we can initialize values if we want. For vectors, it is going to be a vector of the type inside of the less than greater than, the identifier. And we can either provide values or provide an initial size. So, primary difference between both is in this language, arrays are not mutable for now. Meaning once we've declared them, we cannot resize them. We would have to basically create a new array if we wanted to. Also, arrays have no publicly available variables or methods like vectors do. We can denote that by typing out any of our arrays. So we'll do my short array. And we'll try and utilize the dot operator, which on an array, this is to be expected, nothing is going to pop up. So we're going to comment that out. And we're going to do the same thing for a vector. So we'll do my short array. The moment I type the dot operator, it's going to give us a list of all of these methods that we have access to. Now, only a handful of them actually get talked about in the course, so just be mindful of what you actually utilize when you use the dot operator and you're choosing your method this way. I believe in those slides, it's pushback, size, I think that might be it. But we'll see more of that a little bit later, so we're going to comment that in. So for vector size, it's going to be the total amount of items inside of the collection, or if we have a vector that has no items in it, but a size defined, is going to get that as well. So for my short vec, we have 1, 2, 3, 4, 5, 8 items. And then on my string vec, we have size of 4 defined. So we can see out size of short vec, and then do my short vec dot size, and we can do an end out at the end of that one, and then we'll do the same thing for the my string vector. So the only output that we're going to see besides the hello world is going to be this two. So really quick, we're going to rebuild and run. And this one should be 8, this one should be 4. Knowing that you have access to this is going to be making looping through a vector a little bit easier should you need to do it the long way. Now to access values from both an array and a vector the long way, because they are both the same. We're going to assign values first, and we're going to use my int array and my string vector first. So the my int array has a size of 3. And to do this the long way, we're going to type out the identifier 3 times. So my int array, and then we're going to put square brackets and 0. So in the slides, I probably went over that when we have collections, we're obviously having a collection of things. So in this case, we're talking about my int array, we're going to have a collection of ints. with collections in pretty much every language, the position at what they start at being stored is 0. So the first element of any collection is going to be at the index or position 0. And same deal for the MyString vector. So we have MyString vector as size of 4. We're going to assign 4 values to it. Do you have any questions on any of that so far? All right. Same deal with scouting them. If we wanted to output them, we would simply do a cout and then anything formatting wise that you want to do. So we'll say we'll output my array at position 0. And we'll do string vector of position 0 as well. So now the bottom two output lines should say to and below. So if you want a specific value out of a collection, you're going to have to be aware of its position. Whether you want to output it, alter it, display it, whatever. If you want something specific out of the collection, you're just going to need to know its index or position. Now for each loop, something that you probably talked about briefly on Wednesday is an altered version of a for loop. The pattern for that is going to be for, so we're still going to use the for keyword. We're going to define a type. So if we're going through a collection of ints, you're going to make an int variable. If we're going through a collection of bools, it's going to be a bool variable, so on and so forth. Colon, and then the actual collection. So, vector or going through my string array as well. Effectively, this is saying for each string in the string collection, we're going to output. you can see the output right there, where the MyString array is a size of 3, and it has hello world and exclamation point. If we were to do the same thing for the string vector, I'm going to put something in between them real quick. So we have something that separates the output from both for each loops, one for the array, one for the vector. Now we're going to see 4 lines at the very bottom that are going to match this assignment right here. So hello, space, world, and exclamation point. Do you have any questions about for each loops? All right, if no questions, we're then going to loop through both the long way. So looping through an array the long way in this language, there is an equation that you can utilize to get the actual size of an array, but we do not have to worry about that for this course. I'm going to put it in notes so you can do your own research. Just don't use it for any solutions in the course until you get to PQ2 where it might be a lot there. When we give you an array, the size more than likely will not change. Unless that's the goal, in which case there will be instructions on how many. However, in the labs, where you see the example input or example output, count the values. That will be the size. So, for this demo, however, we have 3 arrays at size 3. We know that we made them. So in this case, to loop through our, let's see, we're going to do our numeric version. So we're going to do my short array. So we'll have the values 1 to 3 output. We're going to do 4 int I equals 0. I is less than the size of the array. Again, there is no method or way accessible right now to get the size. So we just have to know the size, in this case 3. And we're going to say I++. And then we're just going to see out each value inside of the my array, or short array. So we have some formatting so we can see where the values are coming from. We see my short array as a string literal. We put I in between the square brackets so we can see the position as well. And then we actually output the collection at position I. The reason this works is because when we start the initialize over statement 1 of a for loop at 0, the order of operations for a for loop is when the compiler reaches it during the execution of it, it's going to run this exactly once. That's the thing that happens first. The next thing is it's going to compare or evaluate the condition. If the condition is true, it's going to do everything inside of the scope braces. And in this case, we're outputting something from a collection. Collections start at 0, and we're looping until we reach the size of the collection. So it's going to output everything inside. So before I do that, I'm just going to create a method real quick, so I don't have to continually draw out lines. And now the bottom three should be the values of 1, 2, and 3. And we can do the same thing for a vector. However, looping through a vector the long way is a little bit easier than looping through an array the long way. So if we wanted to loop through the short vector, the structure is going to be similar to this, but instead of a hard-coded value right here, we can actually use the size method. So again, for int I equals 0, I is less than my short vec dot size, so the size of the vector, I plus plus, and then we're just simply outputting formatted of my short vec, putting in the value of I between the two string literals, and then the value at the position of I for my short vec. So it should count 1 through 8. We do that with strings. So same deal. So question from online is how would we do that with string instead of int? So if we wanted to go through both the string vector and string array, the string array should have the size of 3. I'll check that here in a minute. So same deal, same loop for that matter. So we can see that the structure on 94 and 109 is the same. And going to be the same deal for the string vector as well. we're going to be looking at the bottom two sections of output for the string array and string vector. These loops, the format of them can go through any collection for the most part. More accurately, it's going to go through any array or any vector specific. The caveat to that is you will have to know the size of the array, where a vector you can just simply utilize the size method. You also don't need to simply output anything. You can alter the values inside of collections with loops as well. So if we wanted to loop through, we'll do myInt array and we'll do myInt vec as well. Or not myInt vec. We'll touch base on that one more time. We'll do myShort. Now this is going to set every value for every position to the value of 22. We can either output in that loop or create another loop to go through it.
So it should be 22, 23, 24, and not 0, 1, 2.
And after rebuilding, we can see the value of every position instead of myInt array being 2.
So they're also 22. Oh, every value is 22.
The next is going to be how to resize a vector. This is going to be important for your midterm and your final. It's also important to note that there is a method available in the language called resize, but as part of the external material use policy, that method is not available for use in the class. So make sure you are not using this method. There is a easier quote-unquote way to achieve the same thing for applying a new size to a vector. So we have 3 vectors. All 3 of them, I believe, have values at this point. And we know that inside of my string vector, it's hello, space, world, and exclamation point.
to provide a new size to a vector, the pattern is going to be the collection in question that you want to apply a new size to, a vector of the same type, so we're about to do one for strings, and then whatever positive whole number value greater than 0 inside of the parentheses. So the myString vector has a size of 4, before altering it. Before altering it, we're also going to just copy and paste this output line, so we should be able to see it before we resize it to 2. Again, not utilizing the actual resize method. And then we can see that the size is 2 after that. So just keep that in mind if you're not familiar. Policy, I would go to episode and look at 0.02 course overview, look for the study guide, should be like the second PDF in there. Page 3, make yourself very aware of that. Because I do see examples of resize throughout every month, I just want to make you all aware of the policy because it could result in a 0 for the assignment, professionals, etc. Now for the last little basic thing for vectors is pushback. Pushback will take whatever is inside of the parentheses of that method and append that value to the new last item in the vector. And while I'm thinking about it, before we even do pushback, we're going to test something with this real quick. I believe after applying a new size to a vector, values get wiped. So we're going to loop through the myString vector here and see if it has any output. So in the output, we're looking for the new myString vector, and yes, the values did get wiped. There's nothing that was stored from the previous version of the myString vector. So just be mindful of when you do apply a new size that the values will be removed. All right, for pushback, we can continue using the myString vector. We know that it doesn't have any values in currently, so we're going to apply a value to position 0 and position 1 before we push back anything. We can output those if we want to. And then we can do some pushbacks. So the size of the myString vector is currently 2. We're also going to output that. And now we can do myString vector pushback. And since it's a method, we're going to have parentheses, and we're doing a string vector, so we're going to have some string value, whether that be a variable itself or a string literal. So I'm doing a list of games in this case. I have WoW and Battlefield 6 in there. We'll do FF14. Now we can output size once more.
Should be 5 because you're adding 3.
And we can copy this loop. And instead of seeing 2 on our first one, we'll see 5 down here. And we'll see all 5 values when we run this.
That actually makes sense. And the run is for the lines that you created for the output menu. That makes sense. So he has the first 2 put down.
So right here, we have myString vector size 2, we have the WoW and Battlefield 6. We then push back 3 things, and each time it appends to the new last item. So Battlefield 6 was the original last item, Final Fantasy 14 is the next, 8 is the next, and so on last. We have any questions on the pushback or applying a new size to a vector before going on?
Yeah, so I'm not confused. Can you highlight the ones that we can't use in class?
When you go to 0.02, it is going to be a non-inclusive list. The golden rule of thumb is if you do not see it in lecture, do not use it.
But you just used it in lecture.
Gotcha.
Like, that's why we'd be confused. If you do not see it in lecture, don't use it. But you just used it in the lecture. So how am I supposed to know not to use the resize method if you just use it in the lecture? He just used it in the lecture. He just explained it in the lecture. If you were ignorant and didn't know anything about what was going on,
Alright. If there are
it
no
would be
questions
confusing.
on applying a new size or pushback, we're now going to see a user input example to populate a collection.
And that's why I prefer ChatGPT. There's no need for condescent or arrogance or speaking down to people like they don't understand when they don't understand. It's not necessary.
And how do I think what we're going to do we're going to create a vector. Int, and we're going to provide it a size of 10. We're going to loop through this collection. With the intent of putting a value inside of each index or position. So to start out inside of the loop, we're going to have to provide some context to the user of what we want. The goal at this point is to populate each index or position of the new int vector with a value. We also have to take note that getLine or cin, whatever you choose to use, will always return a string, so we are going to be forcing the conversion. We don't have to worry about forcing the user to provide a numeric value. Just don't type a non-numeric value when you do your tests. We need a pair of variables now to hold the user input and store the converted input. Now we can allow the user to type and store the value. Now we'll convert that value and store it in the int variable remained. The last part is assigning that value to the current position of the vector. After that, that loop is pretty much done. If we wanted to go through and output all of the values in there, we can make another loop or put the output in the loop where we assign values. Doesn't matter which. So now, after we rebuild this, run, we're going to be prompted this 10 times. So it doesn't matter what you type as long as it is something that can convert from a string to an integer. Like I said in the instruction, the comments, we're not going to care about validating that it does. So this is what's going to happen if you type in something that's not a number or something that could convert to a numeric type. So I type in ASD, we're going to get a runtime error, gives you a bunch of garbage. It pops up the string library and it says invalid argument at memory location. Basically, a very complex way of saying that you're trying to convert something that's not convertible to an int. But actually going through it, we're going to see, I'm just going to type in a couple random values. And we can see they're stored and being output with that second loop. Right there. This type of thing is going to be extremely important for your midterm and your final. I would recommend having a screen cap or copy it down, or after lectures, it's going to end up on ED1. And we can see they're stored and being output with that second loop. Right there. This type of thing is going to be extremely important for your midterm and your final. I would recommend having a screen cap or copy it down, or after lecture, this is going to end up on the PG1 announcements channel in Discord. So if you're not in Discord and you have not copied this down, take a screenshot, etc. Make sure you sign on to the school Discord and accept the proper role. That way you'll be able to download this. On top of that, I'm going to put a note of that right here. When you go to download this from Discord, there is a high probability that your antivirus will flag this as a Trojan or a virus and reject it automatically. You'll have to temporarily disable your antivirus output or create an exception. The process for both is unique to whatever antivirus you have. If you're not accustomed to doing this, I would recommend the YouTube tutorial or ask me on Discord. And I'll put my contact info at the top of this file. All right, that is pretty much it for the live demo. Is there any examples, day 1 through 6, any material that you want to see a different example on?
Your call has been.
put. I did, yeah. I don't think that. No, adjust these. 5 and 6. I already started it, but I want to. Right, this is done. So I got 3 more left, and then this one is fully done. It's completely done. Okay. So the other thing was lab method. Three. I think it was 3. If it's not right, don't understand. If I don't understand it, don't do it. Okay. So first we're going to go.
consisting of a return statement as the end. We have the little, what I also like to do of it, so the multi-line comment that I put above the verbiage that you want, I'm going to do calculate return to string, and then I concatenate end using the plus.
Code, I talked about this a little bit previously. But because if we variable this here, in your ID, say it has a menu. It says as in a runtime, and they code plus stuff we would cover. Yourself, apparently no, have up. Cool. So, but, and, so that means, right, thing, copying and pasting my code, then it's probably a real better way to do it. Up here means we should see all of that code. We see all of this. It actually paused it at cn.get. So this is actually hasn't gotten to that code yet. A bug may potentially be, right? Nothing happened, and it's gonna say, okay, here, and then age. I want to see if this will even let. Say that. Yeah.
Maybe the string again.
65. Multiplied it by 3. And std to string. When I'm going through one of these tests, is I'm going to identify is return 0. Does that make sense? Detail tomorrow, but this is, and try to open a solution. This will not work. This value here. When you open up the debug, from this code, and there's 2 different videos on how. If you bingo banco, integer value of 0 every time it runs. This value that here that return that fall. So make a new folder for your project like this, but the debugging exercise absolutely will. This does not mean that the application is broken. This means that it opened up the project, but it didn't open up a specific file in the project. When you create a new project, it by default opens up the default CPP file. Opening up a new project, open up an existing project doesn't do that. So you will need to open up your Solution Explorer, locate the studentwork.h, and open that if you don't see anything. Inside of that file, you're going to see a series of tests. These are basically worksheets. The test will look like this. There'll be a block quote, and the block quote, or the block comment will have instructions on how to complete the test. So this says, given an integer parameter number, return the given value multiplied by 4. An example input is 5, and an expected output is 20. So if you are given 5, what I expect to see out is 20. This is the parameter. We'll talk more about this in detail tomorrow, but this is the variable that will be assigned that randomized value. So number is going to be equal to some random number between 0 and 10. So in this case, if number is equal to 5, I want 20 out. This value that here, that follows the return, is the value that is given as a result of this method. So if I were to run this right now, I'm going to see output that looks like this. This says input was 6, expected output was 24, and the received output was 0, which means number was equal to 6. I expected to see 24, but what I got was 0. So these are all the randomized values you were given. This is the expected value that I want to see out based on the given value in the instructions. And right now, I am only getting 0 because all this method ever does is return 0. Does that make sense? Any questions about this so far? Cool. So, 2 key things about this method. Right now, it has an int return type. Remember how I said we're going to define this method and it's going to have some kind of value or type, just like we define variables? That's what this is right here. This means every single time this method runs, it should result in an integer value. And right now, it's resulting in an integer value of 0 every time it runs. Nothing other than 0 ever comes out of here. So the first thing I want to do when I'm going through one of these tests is I'm going to identify what type of variable or what type of value I want out, and I'm going to make a variable of that type. So now I said, okay, instead of literally returning 0 every time, I'm going to make a variable that I'm going to store the results in, and by default, I'm going to store 0. Then I'm going to change the return to return the value stored in result, which means, for those of you keeping track, if I were to run this right now, it would still be 0 all the way across the board because I never changed the value of result. But now I have a box that I can change the value out, the output value of, right? That make sense? Cool. So now is a good time for me to put some comments, initialize the placeholder result, return the result, and then between here and here, all I need to do is basically write out the instructions, because the instructions will more or less tell you what you need to do. So in this particular case, I need to set results to number multiple. instructions say, right? So I'll just do that. Result is equal to number multiplied by 4. And now when I run this, we're going to see everything passes. Bingo bongo. So you will repeat this for about 10 times for each lab. There's going to be about 10 tests for each lab. Most of you value of results, but now I have a box that I can change the value out, the output value of, right? That makes sense? Cool. So now is a good time for me to put some comments, initialize the placeholder result, return the result, and then between here and here, all I need to do is basically write out the
So it should be. Return volume.
instructions. Because the instructions will more or less tell you what you need to do. So in this particular case, I need to set results to number multiplied by 4, because that's what the
So this should be set value to set value to parameter that returns string value. Set value to parameter that returns string values. Return value. Value to create a method. Can't and return. Oh, I see. It should be this up here. Create can't. Get rid of it. Value placeholder. Combine frequent and strings into one question. Parameter returns. Plan. Create a string value to hold a final sentence. Plan first, second, third with single string frequently time. Combine question mark to the end. How did you get all of that from this to do? I agree. I see. This value return value, return value. Step in question 2 value. This is interesting. Okay.
std, or maybe all of this doesn't need to be here. No, that has to be there. Oh, I think I understand. This should be input 1. And this should be input 1. Input 2. This should be input 2. And then this should be input 2. And then this should be input 3. And then this should be input 3. And then there's a question, there's a plus sign here. And then I think I got it. Build. Nope, don't got it. Maybe this was right the first time, and it was missing that plus sign. C, B, A, C, A, B, C, and then I think it was missing with the plus sign here. Rebuild solution. I think that's it. Think I got it. But I don't understand. Don't understand. No, it didn't work. So it's not correct. It's structured properly, but it still didn't work. And I don't understand. Because I don't, there's a disconnect between input and this, and I don't understand what's the disconnect. I'm pretty sure this is working as expected, but there's a disconnect. I think I don't know. Return, I don't know. So I changed all these to input 1, input 2, and input 3 because I think I need to pass this to those, but I think I got it. I think I got it. I think looking at this structure, I think I understand. I think it should be this. STD dot string value equals concat. This is the parameter field. But see, where did the okay, I understand now. This is string part one, first plus second plus third. To string test 6, so this needs to be up here. Come on, can't. First, second, and third. Okay. STD string concat. And then STD string value equals A plus B plus B plus C plus question mark. A B return value. And STD string equals A B C return value. Let's see if this is working now. STD test, STD string value, concat, input 1, input 2, input 3. I'm gonna get rid of this.
STD string. Return string value out. Return value. STD string value equals. I think I got it. STD, no, it still got errors. STD string concat. String value out. A. My 293. Concat value. STD string value concat. Maybe this is supposed to just be value now. STD string value C equals value to return out C. Return value out. Brackets.
ChatGPT was thinking about it. Everything is right except there's a typo here. Concat and concat. It's even highlighted, but staring at it, I can't see. Our brain doesn't. There's a disconnect with the syntax error. So it should be. Let me go back up and look. I'm gonna change one character and it should run concat. So this doesn't need the end. Concat. Concat completely is gone. Build solution. And there it is. And now it should be working. And it's still failed. I don't know why it's failing. This is the same issue I was having when I first was doing it. Something is amiss. Something in the structure is off. I should do it this way. Should definitely do it this way. And then wait for it to update and then do the other stuff. Talk for 19 seconds. We're getting to a point where this is part of last week's assignment. Most of this week's assignment is done. I just have to make a few tweaks in regards to using external output data. I'll delete this now. I don't understand. There's something about the concatenation structure that I just don't get. It's outside of my comfort zone. And it makes me sad.
Concatenation function using empty strings rather than spaces. Do I have too many spaces? Your super close flare is coming from your concatenation helper. Value out. What's wrong? You're joining with empty strings, so you're not inserting spaces between the pieces. That's why output shows welcome, how are you, man? So space. Replace the building line with exactly one space between parts. And no space for here. So space, 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 and then no space. Rebuild solution. Close. Rebuild solution. So the spaces was preventing it from passing the correct checks. 7 still fail. Student string equals concat equals input 1, input 2, input 3. There's a keyword that I'm missing somewhere. I don't know what it is. Something real simple. STD string concat STD string A, STD string B, STD string C, brackets, STD string value out equals value out equals A plus string plus rebuild solution. Six still fail.
something is wrong with the way that ChatGPT is providing me feedback. It's the only thing that could be an answer. There's something that it's not telling me. It's holding back some information. You're adding extra characters. Does not. Plus does nothing. And the final question contains a question mark, so test probably don't expect. Instructions say call the method for test 6 part 1. In part 1 you likely had 2 arguments, concat A and B. You should reuse that instead of redefining the third concat. String test is concat std string input 1, constant std 2 string 2. I can't do it that way though. I need the empty strings. And see if because they want me to do it in such a simple way, I can't get ChatGPT to explain it to me. So I will never understand how to do concatenation because there's no way for ChatGPT to explain it to me. If I do this, call the method for test 6. It'll never do it for me. It still won't work.
came up for I need to actually I think I have about 5. Change this to 8. To 11. And 8. Change this in there. Return value. Return value. Value placeholder. Set value. Return proven ordinal. Based on comparison. Value placeholder. Use an additional statement to check the primary return. True or underground. equals denominator. Set value. Yes. If input value equals true value. Return value. No weight comparison. Value. Define. This is super old. This 6 November set. Interesting. Continue. Oh, I gotta unzip it. You always have to unzip it. Download. Extract. Oh, this is awesome. This is exactly what I had wanted. I actually had wanted this. This is perfect. I was watching the actual video thinking to myself, man, it'd be nice if I had that actual file.
Because when you're copying information, you can make mistakes. If you make mistakes, then you have a misunderstanding. And if you're using your notes with wrong information to actually teach yourself from, then you're gonna just teach yourself the wrong thing over and over again. This is actually his lecture notes. So this is perfect. This is actually perfect. This is the same stuff that was on the screen about an hour ago. It's gonna be super helpful. This is November CPP. Okay. I need to put this. Oops. Cut and then move it to C drive. PG1. Yes. Put in starter files so I doesn't confuse me. Okay, I'll leave that there for now. That's gonna be super helpful. Super, super, super helpful. And then November 3 notes. This will be helpful too. PG1, but I put it in starter files. Paste. Okay, now I need to go back to now I need to go back to this. Bring this back up. These labs were already done. They were just done wrong. So I'm just gonna make sure that what worked correctly and what was acceptable is just used again. Because life be lifing. I'm trying to go take a nap so that I can try to actually work on the other training values. Return value. Yeah, I know you're gonna be sad. Test 2. Before I do that, let's see if we can figure out what we're gonna say. Use a condition statement to decide if you need to convert to kilograms or pounds. Define a set value. Determine if value is Celsius or Fahrenheit. Oh, if value is kilograms or pounds. Return if true pounds, if false. Determine if value is kilograms. Return true or false. Determine if value is true or false. Determine if value is true or false. Return value kilograms or pounds. double result. Double to boolean. Explicitly use a double to a boolean. I mean, no, you can't. Wait. It's fine. Value placeholder. Define value placeholder. Define boolean value. Return value. Yeah. To LP brackets killed LB result equals 2.2 value, which is why I'm using value equals input, which is here, times 2.2. Else value equals input times 0.45. Return value. Build solution. Tons of errors. All of the errors. Value double equals 0.0 value equals input. It's gonna be the stack. I see it. It's right here. That should fix it. Rebuild solution. Should all go away. Yay. And now we should say pass. Pass and pass. So that is done. Oh man. Makes my brain hurt. I need to value place over. Just keep writing it. Return value. set value. Value. But what did I say up here? I said value. Yeah, value placeholder. Define value. Define value placeholder. Set value. And I don't feel like doing this 1,000 times, so I'm gonna just do this. Okay, and then let's get test 3. Character 3. Character 3, test 3, double grade. Read this. Use a conditional statement to choose the letter grade based on numerical grade. Return the letter grade. Return the letter grade. Return the letter grade. Use a conditional statement to choose the letter grade. Conditional statement. Define letter. Define grade with statement. Use a conditional statement. Use a conditional statement to choose the letter grade based on numerical grade. Use a conditional statement to choose the letter grade based on numerical grade. Define grades conditional statement. Versus set char equals value equals char value equals string char value equals string. The character value will be defined by this string. Return value.
Returned value. So here, every if else ladder. If else ladder sets. Maybe that's wrong. I'm not sure. Not worried about it. Just doing what I was told to do with the level of with the level of information that I currently have. If it's wrong, so be it. If if there's no easy way to do this. F grade actually, I think there is an easy way to do this. No, there's no easy way to do this. Alright, time to start typing. If grade equals is greater than or equal to 90, grade greater than less than equal to 100, value equals a. If grade if grade is greater than or equal to 90 and n, if grade greater than or equal to 90 and n, grade less than or equal to 100, and there's another set of parentheses. No.
this to B. Put this back. And one of these, right? Okay. And then, oh, now it's actually is easier. Now I can just copy all of this. Boom. If else C. And then make this 73. Make this 80. If that should be there. If else 3, 73, and an 80. Value is C. And this should be capital B. This should be capital C. Copy. And then back. And then back up. And then it should be D. And then it should be 70. This should be 73. 73, 80, 70, 73. And these are all right. Less than equal to 0 and create less than equal to 0 and less than equal to 0 and less than 70. Boom. Boom. This is gonna be F is 0. 90 and in 100. Y equals A, B, C, D, F, else. Where's not equals value equals return the value. Bring this over. Yeah, bring field 0 or above 100 states. Question. Else value. Save. No. It's all broken. All broken. Okay. It's to be expected. Value. Else. Right here. This one. And just like that, all fixed.
I broke it and then I fixed it and it passed. 99% of your errors in coding, let's say 98% of your errors in coding are going to be syntax errors. The other 2% is going to be everything else. Test 4. Return value. Using additional statement to determine if the year is a leap year or not. Return use a conditional statement to determine if a year is a leap year or not. Return the resulting value. Use a conditional statement. Use a boolean. It has to, I think it has to be true. Return boolean leap year. Return true if leap year. Return true if year is a leap year, else false. Return leap year. Return value leap year. Return set value leap year, set leap year value to true or false. Return value. Define value placeholder. This isn't, I think it was trinket. Define boolean placeholders as using bool. I don't think these notes match what I'm doing, but I'm not gonna worry about it. Trying to set it up the way he asked me to. Return value.
has to be equal, doesn't it? Equal equals value. Can I do that? Let's see. No, it has to be equal. Return equal. Or maybe it doesn't. Maybe it's. I screwed up somewhere. Oh, I see what I did wrong. Oh, I see what I did wrong. It's always a typo. It needs to be there. Bool value equals divide by 100 pipe. Divide by 4. And this needs to be gone. Exclamation point, divide by 100, return value. Rebuild solution. And we run. It passed, but it is giving me errors. Do I care? Comparison operator has a higher precedent than bitwise operator and check operator 247. Not too worried. Oh, here it is. This is wrong because it should be a percent. That is me using the debugger. It was literally saying that I had the wrong symbol right there for the operation. Even though it was working, I had the wrong operation, the wrong operator in that spot. So now it's correct. Test 4. Okay, and let's move on to test 5. Test 5, string. Define placeholder string. Call the method from test 5, part 1. Create a method called severity that accepts an integer that represents severity of the return associated. Return severity. Return severity value. Return severity value. I think it might have to be defined as severity. Test 5. No, it doesn't have to be severity. It can still be STD strain. Test 5. I think it'll be okay. Test 5. Part 1. So we'll get our food on. It's time for food again. We're gonna make chicken. Tossing things in the oven and forgetting that they exist is my favorite way to cook. I really want to finish all these classes. I want to finish all 3 of these labs before I go to sleep. I'm either gonna finish all of them or I'm gonna go to sleep at 6 o'clock. So many. Why is there so many? I'm being nosy. I've got so many notifications. Lots from nothing. Most of them are from just me live streaming my 2 cents. You just touched down in your epic pod space energy tool. Should we watch this? Let's watch this. Space engineers too, baby. Looks nice. You want to know I'm really looking forward to? Hermitcraft Season 11. Can't wait. Look at this. Can't wait. The hermits are gonna do the work. Good time to start with Scar. Cup fan. Yep. Anyway, that's enough of that. Let's get back to being an adult. As much as I don't wanna. String, STD string. Value. return value, capital V this time. STD. One of these. STD strings regarding its extra level, and then we're going to do that. Lowercase value equals empty string. Switch. Level. Case. Value equals I don't know how to do that in school. Case 4, case 3, case 2, case 1, value. Oh, it should have looked great. BREAK, break. Should be there. And this could be formal. Formal suspension. Termination. Verbal reprimand, formal reprimand, suspension, termination, and return results. I don't think I'm supposed to use 2 returns. Return value. We can work on that later. Part 2 is string test5, std string test5 and value. Define defined value placed value string, get message from severity. Equals value. std dot string value equals value input return value severity return severity return value input. See if it's broken. Rebuild solution. Looks like it's working. Define value. Well, this would be here. I think this would be here. And I think this would probably define place on the screen. Test 5 failed. Test 5 is not working. Probably because it should actually be severity. Don't understand strings. Test 5 is passed. And let's see if we change this value to severity. Just copy it from there. It's fine. No, it passed because something about the way they have the class structure requires that to actually be severity. So it has to return severity as the actual value for it to work. Updating those, and now it works. Save. And then 6. Pass parameter as an argument for the method call. Create a method call is right triangle that accepts 3 integers which represent the 3 sides of a triangle. Determine if the triangle is the right triangle. Return true. Return true value if right triangle. Determine if right triangle. If right. Determine the value if right triangle define value plus or for right triangle. Define value placeholder for triangle. Determine value if right triangle. It didn't work. It didn't work. Boolean value. Boolean value equals false. Integer a equals a times a. Integer b equals b times a. Integer c equals c times c. If a plus bb equals c, result equals true. Return result. Oh, it's two statements. Oh, but this needs to be it might be time to go to sleep. I think it's time to go to sleep. once I start making mistakes. This is where I'm gonna stop. Go to sleep, wake up, and knock the rest of it out before Sunday night. Um, these streams are super long, super boring. I know they're long, I know they're boring. I'm just doing this for part of run day and actualization and showing people how the process goes. The world, the internet and the world has moved us to a place where we just believe that it's magic. Like you just wake up like, yeah, I know how to do all this stuff, and that's not. This is what adulting looks like. It's a very slow, monotonous process. It's the same slow, monotonous process that we did as kids. We just forgot. We just forgot how much it sucked to sit in class, how much it sucked to listen to our teachers tell us to do things a certain way, and you get to a certain age and you just forget about the foundation of standing in line, sitting in the lunchroom, and going through the motions of life. So that's what I'm showing. Like that's how you get, because I'm trying to make this epic all-female fighting game, and 2 or 3 years from now, when it's out, people are gonna be like, "Oh, how did he do that?" Well, here's all of the hours that it took to sit down and unnecessarily do dumb stuff to get from where I was to where I want to be. So, as always, my name is Paul Emerson. I'll give you my 2 cents.